Hi guys, I am Anant Khandelwal. Today I will be presenting my paper titled Fine-Tune Longformer for Jointly Predicting Rumor Stance and Veracity. So these are the outline steps which I am going to present. There are various news and events which are being available over social media and daily put upon that. But this can be a rumored news and event also. So to identify that, we have solved the task of identifying the veracity of a rumor and their stances also, as and we have taken the dataset released at Samuel 2019. So this task is actually released two subtasks, which is to identify the stance and the veracity. So we have proposed to use a hierarchical multitask learning framework, and this has been helpful for the social purpose that it can reduce the manual work to identify the rumor, news and events. It can be a possible automatic method using deep learning to identify the rumor and the stances. So this so there are a lot of the current status at Rumorwell 2019 is, and the pupil can identify either the stance or the veracity. The top performing method either can efficiently detect the stance or veracity, but not perform well on both of the stars. So these two, but we have seen from lot of earlier studies that these two tasks are interrelated, and actually the stance evolution can provide a important clues to identify the veracity prediction. So we have handled various challenges in this work to handle the different textiles and the level of complexity of each of the dataset obtained from various social media platform, obtained from Twitter and Reddit, data obtained from Twitter and Reddit. So the length of conversation actually is smaller on Twitter and Reddit is larger. So we have figured out a way how to handle that. We have extracted various features for each post to if there is a limitation in the text, uh, then we can identify using the feature what should be its stance and veracity. And so to identify the stance of each post, given the neighboring post in the conversation thread. uh, so we have actually leveraged neighboring post contents to identify the stance of each post, and also leverage the stance solution for identifying the veracity of a complete conversation thread. So our approach is basically made on based on four main ideas: multi-turn conversation modeling, which is the use of Longformer, which is a variant of a transformer trained from robot to checkpoint, and but has a maximum position embedding up to 4096. So this facilitate us to actually fed the whole conversation in one go, identify the stance evolution, and then the veracity. So it has also the facility to configure the window size of self attention. So to actually all these retrained models like BERT and XLNet, all they use the global self attention, but we can use the local self attention with a particular window size. And since there are multiple stack layers, so the field of view is actually a complete conversation only. And this can be an added advantage like we have in the CNNs in the case of this long form. And its long form is actually is currently state of the art on various conversations like hotpot QA, trivia QA, etc. And we have the features which we have extracted, which is called as word level, post level, and psycholinguistic features called as NLP features. Joint learning framework is called as hierarchical joint learning framework, and the ensembling is called as top NS fusion strategy, which is based on Bayesian model averaging. So the our model architecture actually contains first to uh, feed the all the post tokens separated by separated token, and the CLS has been actually used to get the vector for each of the post at the end. So once after this passed from the transformer pre-trained transformer layer obtained from Longformer, we'll get the CLS representation for each of the post, and we masked all those representation get the CLS representation. And at that point we have concatenated the NLP features called as F1, F2, total FN, and the various types of sentence encoder we have used. There are three types of sentence encoder which will come next, and after the sentence encoder we get the fine-tuned representations H1, H2, and Hn, which can be leveraged to identify the stances for at the post level, and the veracity at the complete conversation level. So the pre-processing which we have used is we have used tweet processor to identify the URL mentions and spacey to split the post into the sentences. We've used the tokenizer which I've released with the implementation of Longformer. So there are various NLP features which we have extracted: the structural, content, conversation features, effective features, emotion, LIWC, and speech ad feature. A structural feature will tell about the structure of the post in the conversation, like how many URLs, hashtags, uh, different type of POS tag, how many question marks, exclamation mark, like these. The presence and count will count to 51 features, while the content will focus on the type of words has been used in the post, like Q and swear words, false synonyms, and rumor words, like we have actually created a dictionary for all that, and to identify those words are present or not into that. So this is 12, and this conversation features is so we have used the paragraph embedding to get the similarity between the previous and the source post for the current post, and also the paragraph embedding feature has been used for the post as a post presentation. Also the depth has been in the since the conversation structure is actually tree like, we have calculated the depth for each post in the conversation. And the effective features which we have used are dictionary of effect language and ANU, which will tell about the various types of effect signals from the post. And FN is actually a tetra sentiment analysis, which give us three signals for sentiment scores. And their emotion sentinet feature also, which can give us the various emotion signals, and blue check model, which can give various signals like hate, anger, and swear, and all those things. So there are also there is a linguistic informed word count also, which have 11 categories plus two categories of sentiment. So we extracted those 13 features also. And the various speech act was, which is distributed over the 37 categories. So we have used those 37 features from a speech act also. So after we get the sentence representation as a CLS representation TI, we then concatenate the feature representation FI for each of the corresponding posts. We get the final encoded representation, which is KI. On top of KI, we will use various types of sentence encoder: identity encoder, transformer, and recurrent neural network. So identity encoder will give out the same representation without processing it, while the inter-sentence transformer operate on the sentence level. That's why it's called as inter-sentence transformer, while it's a basic transformer only, having various operation: multi-attention layer, normalization, feed forward neural network, and feed position embedding. So we have used only two layers, which works best for us. And also we have used the LSTM also over the KIs to get a final representation, fine-tuned representation HI. So once we get these fine-tuned representation, we apply the softmax and the cross entropy loss function to calculate the loss and the final predicted label. And we sum these two loss functions parameterized by the lambda, which can actually control how much the stance is important to identify the veracity or not. So so the ensembling so next we will discuss the ensembling. So our model Longformer, which is just a base model, and there are various sentence encoder has been used to learn the various features for stance classification and veracity. So we have trained the 50 models by varying the sentence encoder learning rates, sentence code and learning rates. So how and once these 50 best model is saved, we then select iteratively one best model, which increases the ensembles one by averaging the pre-softmax scores. So once there is no increment in the ensembles F1, we will stop. And it has been so this ensembling strategy is referred to as top NS fusion strategy, which is based on Bayesian model averaging. So this data set, and this is the data set description for per class and the total data set we have for each of the tasks, task A and task B. And we seen that in the task A, the rank for system which is submitted to uh, this Samuel 2019 have a F1 score of 0.6187, while we have a proposed method which is ensemble model on the DEF models will get a maximum score of 0.6720. So we see that the models which is relying which is named as which is which is in the DEF are their counterparts which is in the ABC, where in the ABC, but in the ABC there is no NLP features, while in the DEF there are additional NLP features. And see there the possible and the obvious advantage of using the NLP feature and obvious advantage of using the ensembling. Similarly for the task B, the DEF models perform better than the ABC with their without the NLP feature counterpart, and their ensemble obviously perform better than the all of these. And we have performed better, actually 1% better than the previous topmost model into them. But our model will be able to perform well on both of these tasks. That's the most important thing here. And we see that that the individual class wise scores also. So the we see that our deny score, f1 deny score for f1 is largest among all, and this is better for us because this can deny the supporting fact and the comment fact also. And once it denies a supporting fact, and which is to which it is more confident our to which is more confident our model is, so it means that it can it can more it can robustly identify which conversation are actually the rumorous conversation. And so similarly we can see that the false rumor f1 is better than all other classes. So we can say that the false rumor has been identified robustly by our model. So uh, this is the case study, which is a conversation thread from a Twitter. So you see that the stances for each of the post, querying, comment, comment, deny, and comment. So as soon as the deny comes, it classifies this conversation thread into a false rumor. And since there is no supporting and querying, comment, and deny only, it can say that we can say that this conversation is a false rumor. So, we conclude this presentation for now, and we have described the multitask approach for joint prediction of rumor stance and veracity for data obtained from a different social media platform, Twitter and Reddit. And we have presented how an ensemble of deep learning model perform better than the individual model. And our approach actually outperforms all the previous approaches by sufficient margin. So we can extend this work to multilingual setting also by using the Longformer multilingual model. And the data set we can use that of Ibervel, which is the counterpart of Rumerville 2019. And we can leverage more sophisticated resources like a pre-trained model, which is trained specifically on the on the social media data sets. And we can use the various pre-trained model for multilingual settings like that. So, guys, I concluded this presentation. Thank you.